Hello students, welcome to Maths Brain. I'm Naveen Elawat. Today we are going to solve example 1 of your NCERT mathematics book. Okay, we shall understand the question first. Consider the numbers 4 raised to n. Some numbers are given represented by journal formula 4 raised to n, where n is a natural number. It means n can take any value from 1 to infinity. And you have to check if there is any value of n among these numbers for which 4 raised to n, it means 4 raised to that number ends with 0. You have to check. Okay, we are going to solve this question theoretically using fundamental theorem of arithmetic and a universal statement. If the number ends with digit 0, then definitely it would be divided by number 10. This is a universal statement. Take any number 70, 80, 100, 1000. If it ends with digit 0, then it would always be divisible by 10. This is a universal statement and we shall start our question from this statement. If the number 4 raised to n for any natural number n were to end with digit 0, it would be divisible by 10. In other words, we can say 10 is a factor of 4 raised to n, right? But 10 is a composite number. So using fundamental theorem of arithmetic, we can write 10 as product of prime factors. What are the prime factors of 10? Let us do. We shall start from the smallest prime number 2. 2 5s are 10. 5 is already a prime number. So 2 and 5 are the prime factors of 10. Then we can write same statement replacing 10 as product of 2 and 5. This implies 4 raised to n for any natural number n were to end with the digit 0, it would have both 2 and 5 as prime factors. Earlier it was a statement with number 10, now we can write it as a prime factors both 2 and 5. But if we do prime factorization of 4 raised to n, what we are going to get? 4 raised to n. 4 is also a composite number. So we can write 4 as 2 multiplied by 2 as prime factors raised to n. Or we can write 4 raised to n as 2 raised to 2 raised to n. Or you can write 4 raised to n as 2 raised to 2n. So in this way, if we do prime factorization of 4 raised to n practically, we get only 2 as a prime factor. 5 is missing here. So it can never end with the digit 0. Okay, theoretically we are going to write using fundamental theorem of arithmetic, it has only 2 as a prime factor. So the uniqueness of fundamental theorem of arithmetic guarantees that there are no other prime factors in the prime factorization of 4 raised to n. So there is no natural number n for which 4 raised to n ends with digit 0. In this way, you have to prove this statement theoretically using fundamental theorem of arithmetic. Thank you. If you like the video, please share and subscribe.